Okay, everyone. I am Che from Kajima Corporation. Let me introduce our the program statement. Our program statement is looking for a solution that delivered materials on building floors to as efficiently as control the building construction and workability. This slide shows the background and current practice. As you know, as the usually in the construction industry, after the building structure is completed, the materials for finishing works need to carried from the loading point to each floor to exact location on that floor where the work takes place. And also, the finishing the works need to many kind of materials such as bricks, cement, and tiles and wall panels come in very safe and various shape and size, and they have to difficult to control all the materials lead the same the situation. And then, as currently we is bring and control the materials logistic in the construction site by only handling by only as the handling by the manpower as physical man. And then we is bring the kind of materials by as manual trolley and field bellows, and also as it is difficult to control and manage and monitoring the all kind of the situation in what happening in the site by supervisor and managers. And then also in each site there are different subcon in charge of different tasks and sharing the same loading site. And then, so just like this diagram, we is the carrying the materials from the lift, and the lift is the loading the all materials on the loading base, and all as kind of the materials is delivered by manually as this kind of situation. Okay, as next slide, and then. So we wanted to find some opportunity to improve our delivering at work at productivity, and we find some the robotic solutions could support on demand delivery on of materials. The materials is that are optimized based on the work process. And then maybe we have the kind of the solution we can get the benefits to this kind of benefit. First one is allow the subcontractor to focus on their tasks at hand and spend less time collect materials from the loading point. And second one is facilitate the driving planning, which would reduce work interruption caused by lack of materials. And third one is the planning of materials will be more timely, which will prevent the project delays. And then, as you show this the benefit, we want to more as the advanced system, not only as robotics, but also the system control management solutions. Okay, next, please, next. And this the table show the detail and the specification as now we are at finding some find this the solution. And the first one type of materials. Ideally, is we want to carry all type of materials, but as study we wanted to focus on the bricks and cement because the two materials very high in demand to carrying on the site. Second one is capability to navigate the building floor with minimal human intervention. And usually we have the broad blower in our site, but sometimes we have some the steps on the blower around the 150 mm in height, and we want to overcome the steps by robotics. And then sometimes we have a slope up to 1 to 12 ratio. And third one is capability to load unloading materials with minimum human intervention. And then also we want to add the ability to carrying load up to 500 kg. And then also we need to as allowance for the full load materials to easy fit through the normal size door, because after in a situation of the floor the finishing at the stage, we have several kind of the wall is already installed, and we need to through the door. The door size is around it as 1 meter, 2 meter. And also we need to some the function to prevent collision with people or structure. And then as manual override or automatic functions. And the last one is the bonus the function. We need to as a solution could potentially be built at the level to support the planning and the management of material delivery by these the robotic solutions, because that there are many kind of the working ongoing together on site. The arrangement of the delivery is need to prevent collision of each work. Okay, please next the slide. Okay, this one is summary of my our progress statements. And there are two expected outcome of solutions. First one is the robotic solution, and the second one is the material delivery planning and the management feature. Okay, that's all for my presentation. Thank you.
Hi, sorry, there was a bit trouble in unmuting.
Okay.
Thank you, Dr. Che, for sharing more regarding the challenge statement. I would like to invite Lord from Soilbuild, which is the chief, he is the Chief Information Officer from Soilbuild, to share more about the additional detailed specification for this solution that both Kajima and Soilbuild is looking for.
Basically, to share with a bit, basically add on to Dr. Chi's requirements. Basically, because I'm not too sure the innovator whether familiar with the build environment, because this build is to load up about loading about 500 kgs. The loading bucket, I don't know, they usually based on our estimation, the size could be up to about 1 meter to times 1 meters. The requirements, because in the buildings, there be a certain condition, the corridor size is basically 1.2 meter wide, which can turn 90 degrees corridors. So I think that one of the challenges during the explore of this kind of solutions is basically the robot need to be able to turn around the corridors, which is 1.2 meter wide. So then another thing is basically also this kind of conditions basically he said this a material which is Dr. Chi was mentioned basically the cement sand and aggregators and some of the MAE items which is requires of fitting up at the rooftop, for example, for residential building, there's some of the lighting part. So preferably if the robot can lift up this material up to 3 meters high above the ground, or if up above the floor. So that means our workers can fit up these materials from this with the help of the robots. Another very constraint is basically indoor environment. So for the robot to navigate to the exact location, for example, just now Dr. Chair mentioned that if you want to deliver to a particular room, so the GPS is not functional. So you have to be able to navigate in the floor to the exact location, for example, for a tile delivered to a bathroom. So this robot need to be able to navigate through the floor and arrive the actual location of the bathroom. So this basically in the indoor environment, the GPS will not work. So basically, when we explore this kind of solutions, so a lot of solution provider come to us. They want to make a GPS work, and when try to the construction site, this GPS may not be able to work. So lastly, of course, you have a management console to allow our supervisor or our planner to place a delivery order from which floor to which floor, and the plan ahead. For example, tomorrow I need this material, so today I can pre-arrange all the delivery way in advance, so the robot can start to work. So that's basically some of the requirements which I wish to add on.
Thank you, Lord Chen. So now we will be taking questions from the audience. This a note to all our online audience. If you have a question specific to Dr. Che or Lord Chen, do indicate in your question. I'll kick us off with a question from my end. So could starting with Dr. Che, could you share more regarding the type of construction project which you are looking to deploy this solution, just to help innovators to understand how to fit to your requirements?
Okay, thank you for your question. And then it's for me, for our as a company, we will use this solution any type of the as a building construction site. And then because maybe you just focus on the special type of the building, and then we need to change every time the robot in each building type. It's not. I think that is not as practical as the using. And then maybe we can design the robot using the every type of the building. It's more as efficient for us, I think so.
Mr. Lord, do you have anything to add?
I think the building properties can split into two types. Basically, one is the residential buildings. So the way do I need to split into two types? Basically, one is the residential building. So the residential building is they have the rooms are quite small, and with the door limitations. For example, Dr. Chen mentioned the door. You need to the robot need to deliver the material passing the door. The door size usually is about 1 meter wide. So so you need to pass this kind of door. So basically, this is one type of the projects. Another project is basically for the industry and the commercial. So that one basically this kind of a door, and they are quite wide, and the ceiling height is not limited to 3 meter wide, and the ceiling is 3 meter high. So, but I think we are more looking at this moment. Probably we are more looking at the residential project. So, but of course, the innovator we are taking consideration future can develop different series cater for example, it started with the residential project first, then develop into a robot which can handle the commercial and the industrial building, which is the floor much wider and but the ceiling much higher. So then probably the scale will be much larger. So basically, I think we are looking. So this is for the innovator to consider.
So we have received a question from our audience. So the first question is, what kind of price range would be suitable for the Singapore market?
I think I pick up this question. So basically, when it's basically for the innovator to be able to consider it, first of all, you need to be commercial viable. And the talk of the price, basically, when don't have something in mind, for example, whether you say that it costs about 100,000 or up to $500,000 or even more, you look at the currently, basically, is replacement of the labor cost, because it's basically currently is purely based on the labor to deliver the material from floor to floor. So with this kind of improvement, you take in consideration, for example, if the construction company do not use this robotic company, they have to use labor. So if, in terms of the replacement of labor costs, look at the scale of development, scale of deployment, how much of the saving you can consider, for example, even equivalent to the labor cost, and you look at this kind of, you divide it into maybe you can, the company can recover this capex. I mean, because the company to buy the robot. So in your few projects, so that's basically for you to consider to price this robot to be able to sell in the market.
Dr. Che, we have any comments to add?
Okay, I think the price is depend on how we can improve the productivity by one as robotics, and then we need to finally calculate how we decided the price for this robot and system based on our improvement point. That means I think it's very simple. So when if we can at least one worker by this one robot, and then that means the robotics is the price is simply we can calculate by based on the manpower cost. Okay.
Thank you. So another question. So we know that automation and robotics have been widely implemented for factories and warehouses. What would you say is the key difference for the solution for construction sites?
Okay, so can I first answer for this question? Okay. And from my experience, the most is different at the point is the environment. The factory environment is very fixed, and there is no change to control the robot. But the construction site, there are many kind of the situation, and there are many kind of the happening. And then that means we need to estimate all situation to control the robot. That's most difficult to design the robot to use in construction site. That means that the situation is include the safety, and then also the kind of the security, and then also how to using the robot and how to operate the robot, and some kind of the all things we need to consider to use and practical as development in kind of the robot in construction site. Yeah.
Just to add on the Dr. Che's comment, basically for a factory environment, the infrastructure setup can last for about maybe 5 to 10 years. So for example, just mentioned able to navigate, to allow the robot to navigate through the construction site. But if you compare to a factory environment, you can set up a Wi-Fi or whatever things, but this kind of setup can be last about for 5 to 10 years without any replacement. But in the construction site, the construction usually is about 24 months to 36 months. So, and the requirements change from the floor to floor. So if when completed to a one floor, is probably about a couple of months only. So for example, when I started to do the architecture and the finishing, is only a couple of months. So if the solution provider need to do intensive infrastructure setup to allow the robot to navigate, to climb them, to be able to deliver the material, then it may not be feasible, because this kind of intensive setup, first of all, requires a capex, and second thing is requires a long time to set up. So if you require a long time to set up, by the time the setup is done, probably by the time the kind of work job already more or less completed. So that's basically one of the significant differences. Then other things, basically in the factory environment, they are more organized. So compared to to the set environment, because as the Dr. Chen mentioned, basically the set environment, all the many trades are ongoing, and there could be safety hazard there here and there. So safety is a very much concern. So basically for the material to be this robot, you need to be safe, and then you need to be able to adapt to the dynamic changes of the construction site. Because the site is every day is a difference. So those are the, I can see the two major difference compared to the factory versus construction site.
Just a final question before we move on to the next challenge statement. So for the robot, does it need to be electric or battery powered? Yeah, and what is the duration we would expect the battery to last?
I take on first, sorry, later Dr. Chi, if you have anything can add on. So
Yeah,
I think it can be a battery operate. I think it have to be a battery operate, because the robot cannot have charger connected and the wireless climbing the different floors. So you have to be a battery operate, and preferably this robot can when the battery low, this robot can just like a self position into the charging station and the charge itself. Of course, if you say the robot can be, the battery can last usually during one day's work, it is about maybe about 8 hours. If it can last for 8 hours, that will be best. But if you can last for 4 hours, for example, one day's half a day, then during the lunchtime, you will charge the robot can automatically go to the charging station and charge himself. Then it should be also workable. So as long as it can last for 4 to 8 hours, and at the end of when the robot detect its battery low, and the robot can go to the charging station himself to charge, to automatic charge. I think that should be sufficient enough.